Okay. So here we go. What do you remember about limits? We're on the limit practice worksheet. Anybody have any idea about the first one? It's the horizontal asymptote. So where is the horizontal asymptote?
Are we on the practice? Over 6.
One more time. We are on the limit practice worksheet that I just handed out. If you did not get one, come up and get one. All right. Number 1. What did you say the limit is? Where is the horizontal asymptote? 4/6. So it's 2/3. So the limit is 2/3. You just write equals 2/3. Now, what about number 2? Different kind of problem. It's divergent, which means no limit. And why is it divergent? Because the number being raised to the power is bigger than 1. Okay? What about 3? 0, because the number being raised to a power is less than 1. And remember, with those kinds of problems, those are your only 2 options. You're either 0 or you are none, no limit.
Do you prefer divergent?
Divergent or no limit, either one is fine. All right, number 4. Number 4 is just like number 1. Where would the horizontal asymptote be in problem number 4? -5. Why is it at -5? Because it's 5n squared over -1n squared. And remember, we only look at the highest power in that kind of a problem. Okay, 5. 0. We don't care about anything except that fraction inside the parentheses. It's less than 1, so our limit's 0. What about 6? It would be 6/4, which is 3/2. The negatives cancel. -6n over -4n. All right, what about 7? 0. It doesn't matter what else is there. If the fraction is less than 1, the limit is going to be 0. Okay, what about 8? 0/1, which is type it on your calculator. What's 0 divided by anything?
0.
0. The limit is 0. Now, why is it 0? What is the highest power in problem number 8? Highest power is n squared. I have 1n squared on the bottom, and I have no n squareds on the top. So the limit is 0 divided by 1, which is 0. Now, 9 we've never talked about, but it isn't difficult at all. What is the limit of the first piece? 4/3. What is the limit of the second piece? 6/7. And we are multiplying these together. So now it says times. So you just multiply the limit of each. That's a property we never talked about, but it's easy, it makes sense. So our answer would be 8/7. Is that right? 10 is another one we never talked about. There's no ends in it, right? Right? So what do you think the limit of 16 is? 16. The limit of a constant is the constant. So if there's no ends, and it's just the number, then the limit is just that number. You're not going anywhere. You're staying right there. Okay, what about 11? What's the limit of the first piece? So 3/2. What's the limit of the second piece? 0. We're adding them together, so the answer to the question is 3/2. And the last one. What's the limit of the first piece? 3/7. What's the limit of the second piece? -2/3, 4/6. This time I'm subtracting them. So 3/7 plus 2/3. I'm gonna get a common denominator. I got 9 21s and 14 20. Did you get 23 21s?
Yes.
All right. They are
What if
in
there's one like first topic, 5, that was it?
All right, let's get our homework out. Oops, that's not homework. And let's work through the limit homework together. Now that we have practiced a little bit, I bet we can fly through this. So I'm looking at the homework 9.4 limits. Most of these you actually work for. What's A? -3. Boys and girls, yeah? -3. All right, how about B?
0.
0. All right, now C is a multiplication.
1/4.
So I need to do my two pieces. So the first piece is 3/4. And the second piece is 1/3.
Yeah.
So when I multiply, I do get 1/3. The answer to C is 1/4. Are we good? How about D? I hear a bunch of zeros because the power on the bottom is bigger. So I've got 0/2 in this case, 0/2. How about E? Divergent because the number being raised to the power is bigger than 1.
If it's 1, is it still better?
No, we talked about that. The limit of 1 is 1.
Oh,
It's
well, no, I meant like.
It isn't gonna be 1 to n, because what is 1 to n? 1 to any power is just 1. So F, what about F? What's happening there? 0. F is 0 because 3/5 is less than 1. How about G? G's another, now be careful. What's the limit of 2? 2. What's the limit of that second part? 3. So the answer to that problem, the answer to G is 5. Now, H is Mrs. Ford being tricky. What does a negative exponent do? Flips it, so that isn't really a 1/2, that's really a
So it's divergent.
2. It's divergent. It's divergent.
Hold me.
I know, I'm tricky. Good thing we did that after the survey. Okay, I.
So we can do
What's 5/0?
Can you do it
Divergent.
again?
Yeah, probably could do it.
Divergent.
It's divergent. Why is I divergent? Because 5/0. 5/0. And then J, I'm gonna do a subtraction. What is the limit of the first part?
4.
The limit of the first part is 4. The limit of the second part is 3. So the answer to J is 1. Good? Now, everybody who's here gets credit for that. Please don't turn it in. Just get credit for it. Okay, now I have something else for you. Please, 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 get out a sheet of paper. Get out a sheet of paper. I need everybody focused, paying attention, and taking good notes. Okay? That's why I had to get the paper out, because it's one thing just to write down what I write on the board, but you might want to, like you do in English class, annotate it a little bit. Okay? So let's take really good notes. How many ways can we arrange the letters of the word, you are my friends? First, we count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 15 of them? So we start with 15 factorial. Then what do we do? We search through to see if we have any duplicates. So I think we have 2 E's, 2 Y's. Yep, 2 R's. O, U, M, F, I, and S. Is that it?
Yes.
Okay, so then we go to our calculator. And we type in. Let's all practice typing in just because we don't want to screw this part up. The big one, 1.635 times 10 to the 11th.
Ready to get your calculator out.
Which calculator? Math is not a spectator sport. Come on, you gotta play. Right. Yes. All right, number 2. How many ways can a captain and an assistant captain be chosen from a team of 10? Now, gather your thoughts. There are 10 people in this pile right here. I'm gonna reach in and grab 2 of them. Is it 10P2 or 10C2? P. Why is it P? Because they're different jobs. So 10P2, I think, is 90, but I'm gonna let you check that out.
Correct.
Number 2, same situation, except now I'm just picking 2 co-captains. That would be 10C2.
That's better. So you can do a bunch of different
All right, everybody good with that? See the difference between problems 2 and 3? Perfect. How many ways can 5 people be seated in a row? What? 5 factorial. Do not overthink it. 5 people in a row is 5 factorial, which is 120. 8 people in a row would be 8 factorial. 25 people in a row is easy. All right. Number 5. Now, I have 5 algebra and 6 geometry books. All right, now they're the same subject, but the books are all different. So it's like on the shelf back there, I've got all these different pre-calculus books. They're the same subject, but they're all different. How many ways can I arrange these books on the shelf? No restrictions. Just put them on the shelf. 11 factorial. So A is 11 factorial, whatever that is, that's a big number. Okay, no restrictions. I just got this pile of books, I'm putting them on the shelf. 11 factorial. The books are all different, but I gotta organize them. So I'm gonna keep all of these together, and I'm gonna keep all of these together. So I'm really, here's my bookshelf. I'm really not arranging 11 things anymore. I'm really arranging 2 things. Here's my geometry, here's my algebra. So I'm gonna start with 2 factorial because I'm arranging 2 bundles. No, I don't divide. I only divide decide if they are identical. These are not identical. However, these 5 could be arranged 5 factorial ways. And these 6 could be arranged 6 factorial ways. Remember, when you bundle things, start with, how many bundles have you got? And it's that factorial. Then you have to multiply that by each bundle factorial. Because when I tied together those 5 books, they can be tied together 5 factorial ways. Alright, so if I'm annotating, and this is confusing to me, over to the side, I start with what? The number of bundles factorial. Right? And then I multiply that by each bundle factorial. Okay. Now, no restriction. So go back to the original problem. How many ways can I arrange these books on a shelf? But the geometry books are all identical. No. It's just like this right here. So what do I start with? No.
Oh, wait.
I start with 11
And then
factorial.
you divide by the.
And then I divide by 6 factorial. So it's like having a word with 6 G's in it. So there's 11 books to arrange. So I start with 11 factorial. But then I divide it always by things that are duplicates. Duplicates mean they are identical. It says the geometries are identical. D. On this one, you have to keep track. There's a lot going on. So, our same 11 books. But I'm not arranging 11 things. Because the geometry books have to be kept together. So I have my 5 algebras and my 6 geometries, but they have to be kept together. So now they operate as one, but I still have these guys. It didn't say I had to group those. So I got my 5 and my 1. So I start with 6 factorial. It's 1 bundle, 5 spare books, that's 6 things. Whenever things are bundled, you have to multiply by the bundle factorial. We just talked about that. But, because these books are identical, I have to turn around and divide by 6 factorial, don't I? And these are gonna cancel, so ultimately the answer is just 6 factorial. Huh? Because the bundle. Multiply by the bundle factorial every time. Every bundle factorial. How many ways can 6 kids be seated in a circle? 5 factorial. Because what's our rule for seating in a circle? Subtract 1. I'm trying to get through all these problems, so I'm not waiting to type it in. On test day, exam day, you will need to type it in, okay? I'm just not moving on. So it's 5 factorial, 1 less. All right, now what have I got in number 7? I'm going to make a necklace, which means I am arranging them in a circle. All right, so that's important. What have I got? 4 red, 6 green, 2 yellow, no mention of a class, so no class. And these are all identical. What does that mean? That means at some point I'm going to be dividing by 6 factorial because we always divide by identical things. Okay? Now, does it say anything about, I don't have to keep anything together or anything. How many beads have I got? I got 12, but I'm putting them in a circle, so 11 factorial. Am I bundling anything? No. The only thing left, and this is a tricky one, does anybody remember?
Look at it.
I can look at it from both sides, so I have to divide by 2. That's called the reflection. We only do that, remember, I know we spent some time talking about this, we only do that if we have a circle that we can hold up and look at from both sides. So basically, it's a necklace, a bracelet, or a keychain. That's about all you got. Okay?
Not 2 factorial, just 2.
Well, it really doesn't matter, but it is just. All right. Okay, that was 7. 8. Find the third term. So 5x minus 3y to the 10. I know that every term of this is going to have a 5x and a negative 3y, right? Every term is going to have that. And every term is also going to have a kind of foundational number there, a coefficient to get us started. That number could come from the 10th row of Pascal's triangle, if I wanted to build it all the way out. It can also come from the combination numbers. So in the 10th row, the first number is 10C10. And the second number is 10C9. And the third number, which is the one I want, is 10C8. So you're either going to build out Pascal's triangle down to the 10th row, or you're going to remember that you can just count down your 10C numbers, always starting with 10C10, 15C8, or 15C15, whatever. Okay, there's one piece missing. What is the one piece that's missing?
You gotta put
The exponents. And they're easy. In the first term, this power would be 10. In the second term, that power is 9. So in the third term, that power is 8. And as soon as I make that an 8, I'm gonna make this a 2, because they gotta add up to 10. Now this one I am gonna simplify out, so I want to make sure you can do that. So what's 10C8? That's 45. Yep, 45. Now, I'm gonna multiply that by 5 to the 8th x to the 8th. So 5 to the 8th is 39, no, 65, x to the 8th. And then negative 3 squared, which is 9, times y squared. So all this is getting multiplied together. 45, 5 to the 8th, negative 3 squared. So your answer, after all that, 158,250,125, x to the 8th, y squared. Okay, Jimmy, try to stay focused, honey. Write this stuff down. It will be in your best interest to have it written down, so please do. All right, so now we have to do 2x plus y to the 5th. And this time we're not finding, same kind of problem, but we're not finding one term, we're finding them all. Okay, so we're gonna start with those coefficients. position's gonna come from either the fifth row of Pascal's triangle, or 5C5, 5C4, 5C3, and so on, all the way down to 5C0. Now, I use all the time, I have Pascal's triangle memorized to a certain point, so that is the fifth row. But again, you don't have all the experience I have, so that isn't on the tip of your tongue. So you either build the triangle out, remember how to build it out, if you don't, get turned off somewhere, ask a friend, Google it, whatever. Or you do 10C10, or excuse me, 5C5, 5C4, 5C3, and so on. This is 5C0. Next to each of these is going to go the 2x and a 1. And then we're right where we were a minute ago. We don't have any exponents. So what's gonna happen with our exponents? Right here, where my finger is gonna go a what?
5,
5,
5.
4, 3, 2, 1, 0. And then 5, 4, 3, 2, 1, 0. And each of these are going to be individual terms. And just like we simplified the last one, you got that good big giant number, we have to simplify these, so these will be a lot easier. Anything to the 0 is 1, so we're not gonna let it bother us. First term is 32x to the 5th. Watch it on the second term. This is gonna be 5 times 16. So it's gonna be 80 x to the 4th y. This one is also 80. Why? Why is this one 80? 10 times 2 cubed. So that's 80 x cubed y squared. What's this one gonna be? Not 10x. It's gonna be 40 x squared y cubed. Because we got a 2 squared in there. This one will be 10 xy to the 4th. And this one is just y to the 5th. Please make as many notes as, I mean, there's the answer, but where did these numbers come from? Make sure you are taking good notes to remind yourself. All right, I'm going down to the lunchroom. That's what we called it when I was in school. Then we called it the cafeteria. Now we call it the dining hall. We have 6 different sandwiches, 4 different fruits, and 2 drinks. How many different lunches could we have? I heard somebody say it. 6 times 4 times 2. That's exactly right, Alden. So I have 6 choices, 4 choices, 2 choices. So it looks like the answer is I have 48 different lunches that I could choose from. Notice there's no factorials, guys. Am I arranging my fruit? I'm picking one. I have 6 choices. 5 people in a race. The top 3 finishers all get $25. How many ways can I do this? 5C3. Beautiful. Why is it 5C3? The prizes are all the same. So you really don't care if you finish first, second, or third. You're going to get $25. 5C3. I need to put some 4 base of 15. The S's stand for sum. I'm not summing these, I'm literally finding the 15th number in this list. So you need to look at the list and figure out what is going on.
That first one's a function, right?
Oh, yeah.
Times 10. 9.
It's not arithmetic, is it? I'm not going down by the same amount. So what am I multiplying by?
Point 9.
0.9. I'm multiplying by 0.9. You can always tell kids 90 over 100, 81 over 90, that over 81. The ratio is 0.9. I don't know how Jackson figured it out, but you already knew it couldn't be arithmetic. So just do the ratio, 90 over 100. Should match 81 over 90 and so on. Okay. Which of these formulas, it's not be one of these two. These are A term. Which one? The bottom one, because this is geometric, it has an R. So we're gonna take our first term, our ratio to the 14th power, n minus 1, that's n. This and this are the same. So my exponent is 14. I'll type it in. And I got 22.877, is that what you got?
So you must have said it's not good. It's the 14th.
Number 13, got 137 kids in the gym. Everybody likes basketball, volleyball, or both. 18 to this, 77 to this. How many like over this? What in the world? Venn diagram. So we have a Venn diagram. And we're going to have 137 kids all together. And they like volleyball, basketball, or both. Everybody does. So there's nobody out here. Everybody likes one or the other. Okay? We know 82 like basketball. So the whole B ball is 82. And the whole V ball is 77. So imagine this. Hey kids, who likes volleyball? 77 vote yes. Who likes basketball? 82 vote yes. What happened? What's the matter? It's too much. This makes 159. So I got 159 votes, but I only have 137 kids. Well, what does that mean?
Couple over like both.
Some like both. How many like both? 22 like both. Because that's how many extra votes I got, right? So then 22 from 77 is 55. And 22 from that gives me 60. Is that right? So now I can answer the question. How many like only volleyball? 55. 14. Read the question and tell me what's going on there. Gotta do a tree. And what are the two pieces of the tree? The temperature and running a mile. And I want the probability I'll run a mile. So I'm gonna start with temperature, good or bad, I don't know. 75 temp? No 75 temp. And then I'm either these problems without a Venn diagram, but it helps me keep things organized to use one, but you don't have to. You won't be counted off. Tree diagram, you won't be counted off if you don't do it this way. This just helps me keep it organized. All right, there's a 94% chance I'm gonna get to 75. So that means there's a 6% chance I won't, and that is a 0.06, not 0.6, 0.06, 6% chance. When the temperature is at least 75, there's a 22% chance you run, so there's a 78% chance you don't. If it doesn't reach 75, there's a 64% chance you run, and a 36%. Do those numbers make sense to everybody? Okay, so I want to run. So 0.94 times 0.22, I get the temperature and the run, or I don't get the temperature and I get the run. So these are going to both be numbers. What am I going to do with those two numbers? Add them. You're going to add them because it's one or the other. I got 0.2452. That's what you got. Alright, so I have a bag that has 3 red, 5 green, and 8 blue. How many ways can 2 red, 1 green, and 2 blue marbles be chosen? So it's not a probability question, it's just how many ways can I reach in, grab 5, and have 2 of them be red, 1 be green, and 2 be blue? No. Well, it's not a probability question, so there is no bottom, okay? Probability, we have a total on the bottom. I'm looking at just the top. How many ways can I get where I want? So, I need to get 2 red. This is like a card problem. How many reds are there to pick from? 3? And I need any 2 of them. I don't care which 2. I need any 2 reds. And then I need a green. How many greens are there? 5, and I need 1 of them. And then I need 2 blue. How many of those are there? 8, and I need 2 of them. So this is just like a card problem. You see that? You got jacks, queens, king. Oh, this time we've got colored marbles. So 2 out of the 3, 1 out of the 5, 2 out of the 8. What goes between here? Am I going to multiply or add these? Multiply. Why am I multiplying? Because I am getting 2 red and 1 of that and 2 of that. That's a multiply. This is the answer to the question. Okay? That's it. So, no, multiply it out. So, I don't know. So it should be 420. Okay? Now, some of you wanted it to be a probability question, and it could be really easily. That question would be worded, what is the probability of getting 2, 1, and 2? So what would change if it had been a probability question? All of this will be over
16C5?
16C5. Because how many marbles total are in the bag? 16. How many total am I picking? 5. So if it had been a probability question, that would be the setup. It was not, so that was it right there, just that part. Do you see the difference? Okay, turn it over, be a more fun and exciting. How many ways can 6 people line up? If 2 specific girls must be next to each other. Alright, so think about that for a minute. I got 6 people up here, but these 2 have to sit next to each other. So isn't that a bundle? That's a bundle. So I no longer have 6 people. I have 4 people and a bundle. So that's 5 factorial. Okay, so one more time, guys. Here are my 6 people. But these 2 have to be together. So that's 4, 5. 5 factorial. But every time you bundle anything, you have to multiply by bundle factorial. So I have to multiply that by 2 factorial. Because there's 2 kids in the bundle. Okay? Sue ate 32 candy kisses on the first day of school. Let's keep track of this. 35, 38, and so on. How many did she eat on the 90th day? Well, aren't we looking for the 90th term? Isn't that what you want to know? That's A sub 90. Which means I'm going to use one of these right here. Top one, because this sequence is arithmetic with a difference of 3. So my first term is 32, just plugging into this formula right here. My first term is 32. My difference is 3. Since n is 90, n minus 1 will be 89. So that's 299 candy kisses she's going to eat on the 90th day. It's a lot. I think I could do it for one month. All right. How many had she eaten altogether after 180 days? How many had she eaten all together after 180 days? You want to add them up? So that would be this formula right here. This is my arithmetic sum formula. Look, this has an R in it. That has an R in it. That's only for geometric, right? So process of elimination, that's your guide. So I'm adding up 180 days worth. So that'll be 180 over 2 times the first day, which is 32. Oh darn it. What goes here? A sub 180? Do I know that? We gotta do this right here and plug that number in up here. So A sub 180 will be what? 32 plus 3 times 179? That is not the answer to the question. That actually is how many candy kisses she eats on the 180th day. So we want to plug that in, add it to 32, multiply. Now even I could do this, I don't think. 54,090. That's how many candy kisses she would have eaten in 180 days. That would cost a lot. All right, last one of the day, number 18. Ice cream shop has 8 different toppings. You can get 3 toppings on a Sunday. How many different combinations are possible? 63. Would you agree with me? 63? Because normal people don't care if you put the chocolate on and then the caramel and then the marshmallow, right? It doesn't matter. Just the whole fruit and stuff. Okay. Oh wait, you give me 19 too. 8 people in a race. How many ways can gold, silver, and bronze be awarded? 8. P3. Because the prizes are different. P3. Alright, so tomorrow, we're gonna finish this up. No, Wednesday, we're gonna finish this up. And then Thursday, we're going to have I have excited, it's gonna be a full-fledged test or a quest over this stuff. Alright? Thursday, no. Friday is your examination. I'll give you the review sheet on Thursday, so you'll have it. Alright. If you are missing for AP things, please take the time to watch this video. Okay?
Oh, I thought you were talking about 18.
All right,